All right, in this video, we're going to talk about section 1.3 dealing with linear and quadratic functions. And in this video, we're going to be finding the slope, y-intercept, x-intercept, using the slope-intercept form of a line, and also going to write the equation of a line given 2 points. Also, we'll be graphing linear equations. Then we're going to be finding the intercepts, vertex, range, and maximum or minimum value of a parabola from its graph. And then we'll use the vertex form of the quadratic function to find information about its graph. Also, we'll be solving linear and quadratic inequalities using a graphing calculator to find information about the graph of an equation and solving applications involving linear and quadratic regression models. There's a lot in this section that I'm going to be covering, so it's going to be a while for this video. So bear with me. First of all, we'll talk about mathematical modeling. That is the process of using mathematics to solve real-world problems. And there are 3 steps for mathematical modeling, and that is construct the mathematical model, and then solve the mathematical model, and then interpret the solution to the mathematical model. And each step done in the context of a real-world problem that is being modeled. So here's a cycle of that model. You have a real-world problem, and then you construct the mathematical model, and then solve the mathematical model, and then interpret that mathematical model. And in complex problems, the cycle may require repeating to obtain the required information about the real-world problem. Linear and quadratic functions can be used to construct mathematical models of real-world problems. Okay. Now let's begin with linear equations in 2 variables. So here I'm just going to give you some information about some things, and then we'll go into some examples as we go along. A linear equation in 2 variables is an equation that can be written in standard form ax plus by equals c, where a, b, and c are constants, and a and b are not both 0. X and y are going to be the variables. Okay. And of course, the linear equation can be written in standard form ax plus by equal to c. Of course, the x and the y are on the left side, the constant terms on the opposite side for a linear equation in 2 variables. A, b, and c are constants, a and b are not both 0, and x and y are going to be the variables. So keep in mind of the standard form of a linear equation in 2 variables. Okay. Now, the graph of any equation in standard form is a line. Now, when a is equal to 0, that means your coefficient of x is 0. You'll be left with by is equal to c. That means y will have to be something like c over b. That line is going to be a horizontal line because you're just going to have y equal to something, a constant. Now, when b is equal to 0, that means this term will be gone. You'll be left with ax is equal to c. That means x is equal to c divided by a, which is a constant. That means you're going to have a vertical line. X is equal to some constant. And any line graphed in the Cartesian coordinate system is the graph of the equation of that form. Okay. Now, next is finding the slope of a line through 2 points. So if you have x1, y1, and x2, y2, there are both 2 points on the line with x1 not equaling to x2, then that means that the slope of the line is going to be this. M is going to be the lowercase letter we use for the slope. That's going to be equal to y2 minus y1 divided by x2 minus x1. Keep in mind, slope tells you how steep a line is going to be. Okay. So here we take the difference of the y coordinates divided by the corresponding difference of their x coordinates. The difference of the corresponding x coordinates, I should say. Now, pretty much most of this is just review from other classes that you might have taken. You might have taken college algebra where they talk about the slope, or you might have taken some developmental math class that talks about the slope as well. And here's the geometric interpretation of that slope. In this case, the slope of a line rises as x moves from left to right. That means your slope is going to be positive. And here's an illustration of that. You can see that the slope is going to be positive because a line rises upward from left to right. Slope is going to be negative, meaning it's going to be falling from left to right. It'll be falling as x moves from left to right. So here you can see that the slope will end up being negative when it falls from left to right. And if you have a straight line going across like this, that means your slope is going to be 0, your line is going to be horizontal. A line like going straight up and down like this is a vertical line. That means your slope is undefined or not defined. Okay. Now here we got equations of lines here. Of course, standard form is ax plus by is equal to c. Slope-intercept form is going to be y equal mx plus b. M is the slope, that's the coefficient of your x. The b, that's the number added to or subtracted from, that's going to be your y-intercept. Point slope form is this. Y minus y1 is equal to m times the quantity x minus x1. That means if you're given a slope and a point, x1, y1, this will be your point slope form. And sometimes you may be given 2 points. You'll first have to find out what the slope is and then use the point slope form. And then your horizontal line, of course, is y is equal to b. That means your slope is going to be 0. The vertical line x is equal to a means that you have a undefined slope. Now, for a line passing through the points a, 0, and 0b, your a is called the x-intercept, and your b is going to be called the y-intercept. It is common practice to refer to a as a, 0. We write intercepts as ordered pairs. A, 0 for your x-intercept, and as the x-intercept, and either b or 0, b. That will be the coordinate for your y-intercept. Okay. Now let's look at some examples of this, of what I just got through talking about. Let's say I want to find the slope and the y-intercept of the graph of this equation, y equal 4/7 x minus 1. Well, by looking at this equation is already in slope-intercept form, where you have y equal mx plus b. Y equal mx plus b. And in this case here, your m, that's the coefficient of your x, that will be your slope. So the slope here is 4/7. The b is the number added to or subtracted from. And in this case here, it's -1. So that means your y-intercept is -1. So here the slope is 4/7. The y-intercept is -1. Example 2. Here we're going to find the slope and the x-intercept of the graph of the equation. 4x minus y is equal to 20. What I would do here in this case is write this equation in terms of y. In other words, I need to move some terms over to the opposite side in order to get y by itself. So what I would do here, and I'll rewrite the equation as 4x minus y is equal to 20. I'll get y by itself by moving the 4x over to the opposite side. And I'll do that by subtracting 4x on both sides of this equation. So that means I'm going to have a negative y is equal to -4x plus 20. Now I got the negative sign in front of the y. Well, of course, y is multiplied by -1, so I would divide each and every term in this equation by -1. So that means I'm going to have a positive y, and that's equal to -4x divided by -1 would be 4x, plus 20 divided by -1 would be -5. So the equation in slope-intercept form is y equal 4x minus 5. So anytime I solve an equation for y, a linear equation for y, I'm writing it in what they call slope-intercept form. From this, I can identify the slope. Okay, that's going to be the coefficient of my x term. So here, the slope here is 4. The slope here is 4. Now they say find the x-intercept as well. Well, let's do this. Anytime you're finding the x-intercept, you always let y equal to 0. And I'll go ahead and write this down. For the x-intercept, you let y equal 0 and solve for x. So in this case here, I'm going to substitute 0 in for the y. So it'll be 4x minus y, which will be 0, equals 20. 4x minus 0 will give you 4x, so 4x is equal to 20. Divide both sides by 4 to solve for x. That means x is equal to 5. Now, it's common practice to write your intercepts as ordered pairs. So my x-intercept will be the ordered pair 5, 0. So here, the slope is 4. Your x-intercept, now abbreviate x-intercept, is the ordered pair 5, 0. Okay. So it's just best to read the problem very carefully to determine what they want you to find. All right, the next example is to find the equation of the line with the y-intercept of 1 and a slope of -8/9. Well, we're given the slope and the y-intercept, so let's use slope-intercept form, which is, of course, y is equal to mx plus b. Y equal mx plus b. And just do some substitution here. Bring down the y, that's equal to your slope, which is represented by m. That's going to be -8/9. So here, this will be -8/9. Because, of course, the slope m is -8/9. Y-intercept 1, that's your b, which is 1. So we do plus b, which is 1. So this is your equation of the line in slope-intercept form. Y equals -8/9 x plus 1. Y equals -8/9 x plus 1. Okay, on to the next example is this. There are 4 parts. Part A is to find the slope of the line that passes through the given points. Part B is to find the point-slope form of the equation of the line. Part C is to find the slope-intercept form of the equation of the line. And part D is to find the standard form of the equation of the line. So here we got 2 ordered pairs, 1, 7, and 8, 15. So the first thing I'm going to do here is find the slope of this line passing through those 2 points. I might need to move the paper over here as far as I can. So this is going to be part A. Now write those points as 1, 7, and 8, 15. And keep in mind, the way you can label this is let x1 be 1 and y1 be 7. The second ordered pair, let x2 be 8 and y2 will be 15. The slope of the line passing through those 2 points would be this, y2 minus y1 divided by x2 minus x1. And then we just substitute. y2 minus y1, that's 15 minus 8, divided by x2 minus x1, 8 minus 1. So if I do 15 minus 8, that will be 7. Divided by 8 minus 1, that will be 7. 7 divided by 7 will be 1. So the slope of that line going through those 2 points will be 1. So that's part A that I just answered. Oh, did I mess up somewhere? 15 minus 7. That numerator should be 7. 15 minus 7. I apologize. And that's really going to change the answer here for everything. y2 minus y1, 15 minus 7. That would be 8. And of course, y2, x2 minus x1, 8 minus 1, that's 7. So I have 8 over 7. So that means that the slope of the line going through those 2 points will be 8/7. All right. So that's part A. Now, part B, they want the point slope form of the equation of the line passing through the given points. Now, in this case, I'm going to use the first order pair. Now, it really doesn't matter which one you use, but I'm using 1/7 as the order pair. And then use that in my point slope form. Y minus y1 is equal to m, the slope times x minus x1. So here x1 will be the 1 and the y1 will be 7. And substitute the m, which is 8/7, along with x1, which is 1, and y1, which is 7, in that point slope form. So it'll be y minus y1, which is 7, equaling to m, which is 8/7 times x minus x1. Now, this part right here that you see is point slope form. So in my MATLAB, you want to make sure that you enter this answer as an equation in point slope form. So we'll say this is point slope form. That's the answer to part B. Now here's part C. Is to find the slope-intercept form of the equation of the line. Well, in this case here, I will take this and just finish this out, just simplify it a bit. So I'm going to bring down the y minus 7, and that's equal to, distribute the 8/7 over the x minus 1. This will be 8/7 x minus 8/7 times 1 over 1 is 8/7. Now we're going to solve this equation for y. We're subtracting 7, so I need to add 7 to both sides. So here you're going to have y is equal to 8/7 x. And in the calculator, I can do negative 8/7 plus 7. So this out. Now I'm going to do negative 8 divided by 7 for negative 8/7 plus 7. And then hit the math key. And then select number 1 for fraction, because I want that in the form of a fraction. This will be 41 over 7. And it'll be plus 41 over 7. So the equation in slope-intercept form will be y is equal to 8/7 x plus 41 over 7. And now part D is to find the standard form of the equation of a line. All right, so here I'm going to do part D over here. So I'll rewrite the equation y is equal to 8/7 x plus 41 over 7. Now this won't have to do here. I have to get the x and the y terms on one side and the numerical terms on the other side. But I got this 7 in the denominator. I can't have fractions here. So what I need to do here is multiply each and every term in this equation by 7. So that means 7y is equal to, these 7's divide out, I have 8x, plus these 7's divide out, I have 41. So I get 7y is equal to 8x plus 41. Now let's move the 8x over to where the 7y is by subtracting 8x on both sides. So I have negative 8x plus 7y is equal to 41. Now it's common practice for you to not have the negative sign in front of the x when it's written in standard form. Usually your x is always going to be positive. So to make that negative 8x positive 8x, I'm going to multiply the whole thing by negative 1. Multiply the entire equation by negative 1. So this will become positive 8x. 7y becomes minus 7y, equaling to negative 41. So the equation in standard form will be 8x minus 7y equals negative 41. Okay. All right, here's another example. You want to find the slope of the line passing through the given points. Find the point slope form of the equation of the line, find the slope intercept form of the equation of the line, and find the standard form of the equation of the line. Here I got the points 6, 4, and 6, 12. So it's part A, 6, 4, and 6, 12. All right, so finding the slope, we use y2 minus y1 divided by x2 minus x1. So y2 minus y1 would be 12 minus 4 over x2 minus x1, 6 minus 6. Let's see, 12 minus 4 would be 8 divided by 6 minus 6 is 0. Got a problem here. Here we got the 0 in the denominator. 8 divided by 0, that's undefined. That means that the slope of the line passing through the 2 points here is undefined. So when the slope is undefined, I know something here about this line. That line is going to be a vertical line going straight up and down. Now, part B. Okay. And even in the homework, they will tell you whether the slope is defined or not. Okay. They give you a choice here, and I can show you that right now by telling you what the slope is, and you have to type that in, or the slope is undefined. In this case, you'll select the slope is not defined. And then part B is finding the point slope form of the equation on the line. Well, in this case, if you take a look at it, here they give you the choice right here. There is no slope intercept form. There's no point slope form because we don't know, the slope is undefined. So in this case here, there is no point slope form. And of course, if there is no point slope form, then part C is this. It's going to be hard for you to find the slope intercept form of the equation of the line. That means that there is no slope intercept form. Now for part D, finding the standard form of the equation of a line. Okay. Well, in this case, if the standard form does, well, of course, there's no slope there, but keep in mind, if you have an undefined slope, that means you're going to have a vertical line. And let's go back to where we talked about this before. Here the slope is undefined. That means that the vertical line would be of the form x is equal to a. And your a is going to be that x coordinate of your ordered pairs. So the x is equal to the common ordered pair you see here for the x is 6. So the x is equal to 6. That's the standard form of the equation on the line for this situation. Okay. All right, now linear function. If m and b are real numbers where m is not equal to 0, then the function f of x equals to mx plus b is a linear function. Sometimes they use the notation f of x instead of y, but they both mean the same thing. Okay. So in this example, we want to graph the equation in the rectangular coordinate system like y equals 4x minus 9. And it might help to write this out. Y is equal to 4x minus 9. Here we can graph using the slope and the y-intercept. The slope is the coefficient of your x term, which is 4. The b, the y-intercept, -9. Now, first we graph the y-intercept of -9. So on this graph, I'm going to go down to -9, which is right here. I'm going to come down to this, draw that point. The slope is 4. Now I'm going to write this as 4 over 1. This represents rise over run. That tells me how many places I need to go up on the x, and how many places, the denominator tells me how many places I need to go to the right here. So that means I have to rise up 4 and go to the right 1. So I have to go up 1, 2, 3, 4, and to the right 1, which will put it about right here. Because this graph, as you can see, is in increments of 2. So if I connect those 2 points, it only takes 2 points to make up the line. That would be your equation. That would be the graph of the equation of the line, y equal 4x minus 9. And keep in mind, I do have videos for college algebra, which talks about some of these basic things on YouTube as well. So you might want to check out the playlist for college algebra and find the one for equations of lines. And I think it's like section 1.4. Correction, 2.4. Because I do talk about slope of lines, and then I talk about how to graph using the slope and the y-intercept. I go into more detail about that. Another example. Since we have the x and the y on both sides of the equation, we can use x-intercepts and y-intercepts. This one says 3x plus 2y is equal to 12. And we can graph this as well. Now I'll show you how to use intercepts as well. Anytime you're finding the x-intercept, you have to let y equal 0. So I'm going to take that 3x plus 2y is equal to 12 and let y equal 0. So this will be 3x plus 2 times 0 is equal to 12. 2 times 0 is 0, so that means we're left with 3x equaling to 12. Divide both sides by 3, you'll get x is equal to 4. So the ordered pair for my x-intercept would be 4, 0. Now to find the y-intercept, we let x equal 0 and solve for y. So here we're going to have 3 times x, which is 0, plus 2y is equal to 12. 3 times 0 is 0, so that means that 2y is equal to 12. Divide both sides by 2, you'll get y is equal to 6. So the ordered pair, 0, 6, will be the y-intercept for the graph of this function. All right, so now let's plot those intercepts, starting with 4, 0. So here I'm going to go to the right 4, and it'll be on the x-axis. 0, 6, we stay at 0, but go up to 6 on the y-axis, and then connect those 2 points. And that represents the graph of the function 3x plus 2y is equal to 12. Okay. Now let's talk about quadratic functions here. And here's the definition. If a, b, and c are real numbers with a not equal to 0, then the function f of x is equal to ax squared plus bx plus c is a quadratic function in standard form, and its graph is a parabola. Okay. Now, the domain of any quadratic function, that's going to be the set of all x numbers, x values, is the set of all real numbers. The range of a quadratic function is going to be a proper subset of all real numbers. So here, methods of finding the range of a quadratic function will be outlined later in this section. I'll talk about how to find the range of a quadratic function. Here's some concepts of quadratic functions. As an x-intercept of a function is also called the zero of a function. Okay. That's where the point crosses the x-axis. Okay, by the way, for an x-intercept, we call that the zero of that function. The x-intercept, or the x-intercepts, if they exist, can be found by solving the quadratic equation y equal ax squared plus bx plus c, setting the y equals 0, and solve for x. Recall that the quadratic equation requires that the leading coefficient a is non-zero. And a common method for solving quadratic equations is the quadratic formula. So here, ax squared plus bx plus c is equal to 0, and a is not equal to 0, then x will be equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The provision there is that b squared minus 4ac, that's this expression underneath the radical, has to be greater than or equal to 0. Has to be. Also, another way of solving the quadratic equation, sometimes it helps by using the method of factoring as well. And I will tell you, I do have some videos for factoring in this course under college algebra resources. If you're weak on your factoring skills, please watch those videos as well, because this will be helpful. Now to the vertex form of a quadratic function. The vertex form of a quadratic function gives additional insight into the properties of a standard quadratic function. All right, so for f of x equal to ax squared plus bx plus c, when a is not equal to 0, your vertex form will be this: f of x is equal to a times the quantity x minus h squared plus k, where the vertex has the coordinates h, comma, k. The vertex can be found by using a process called completing a square. Also in college algebra, I did talk about how to complete the square in one of my videos for chapter 1. Please watch that video if necessary. The vertex can be found using a graphing calculator technology, and other analytical processes can be used to find the coordinates of the vertex as well. All right, so here's some properties of quadratic functions here. When you have f of x is equal to a times the quantity x minus h plus quantity squared plus k, if your a is not equal to 0, then the graph of f is a parabola. Now, if your a, which is the number in front of the parentheses, is positive, your graph will be opening upward. Or if a is less than 0, if it's negative, the graph opens downward. The vertex has the coordinates h comma k. So in other words, if here in this case, when it's written in standard form like this, you have to take, for your h, you have to take the opposite sign. The k is the same sign for h comma k. The axis of symmetry is x is equal to h. The value of f of h is going to be the minimum whenever a is greater than 0. The value of f of h will be your maximum whenever a is less than 0. That means your number in front of the parentheses. If it's positive, then that means you have a minimum. If it's negative, you have a maximum. The domain of the function is a set of all real numbers. The range of f is a set of all values greater than or equal to k whenever a is positive. And the range of f is a set of all values of f of x less than or equal to k whenever a is less than 0. Okay, now here's the illustration of the graphs of the quadratic functions here. If a is positive, that's the number in front of the parentheses, it opens upward. Now, if your a is negative, less than 0, it opens downward. So here's a couple of examples, or a few examples that I have here. In this case here, we want to use the given graph of the function to find the function information. And in this case here, we want to find the intercepts, then the vertex, maximum or minimum, and then the range. All right, in this case here, let's start with the intercepts. That means the points, the x and the y-intercept to be exact. That would be, in this case, the points where it crosses the x-axis, the graph crosses the x-axis and the y-axis. So for part A, let's start with the x-intercepts. Where does this parabola cross the x-axis? And in this case, it's crossing the x-axis at x equals -1 and at, let's see, 1, 2, 3, 4, at 5. So at -1 and at 5, those are my x-intercepts. So my x-intercepts will be the ordered pairs -1, 0 and 5, 0. Now, I'm not sure how they want this as an answer when you do this, when you're typing your answers in MyMathLab. They just might want -1, 5 as the two x-intercepts, just those x values. Now for the y-intercept. Where does this graph cross the y-axis? And in this case here, if you look at it, it's crossing the y-axis at, here's that point, at 5. So the y-intercept there would be, they may want this at 0, 5, or they just might want 5. Okay. So pay close attention to how they want you to type in your answers here. Part B, the vertex. Now, in this case, it is going to be an ordered pair. The vertex, if you look at it, it's going to be, in this case, the highest point that it would ever reach. So here's the highest point way up here. So it's going to have to be the ordered pair, 1, 2, to the right 2, and up 9. So the vertex is the ordered pair 2, 9. And a vertex is an ordered pair, so you have to write that as an ordered pair. Part C is the minimum and maximum. Well, let's take a look at this. This is opening downwards, so that means we have the highest point way up here. So that means we have a maximum. And of course, I'm going to go a little further. It's the maximum value of what point or what value. And in this case, the highest y value here, when we're dealing with the maximum value, we'll have the highest y value of, in this case, 9. And you can also get that from the vertex here. The highest y value there is 9. So that maximum is going to be 9. The range and in this case here, the range, they want this as an interval notation. Now, later on, I'm going to talk about what interval notation is. But if you remember interval notation from college algebra, you would know that it will have to be using infinity, using two values, using parentheses or brackets. In this case, the highest y values are 9. So we have to use negative infinity up to the maximum value, which is 9. So it'd be negative infinity to 9 as your range. Okay. All right, here's another example where we're going to be finding the intercepts, the vertex, the maximum and the minimum, and the range for this graph. And if they give you the function g of x is equal to, and I might as well write this out, g of x is equal to x minus 2 quantity squared minus 1. So here I want to find the intercepts, starting with the x-intercepts. Anytime you find the x-intercept, you want to set g of x to be equal to 0. So that means here I'm going to have x minus 2 quantity squared minus 1. That will be set equal to 0. And then I'm going to solve this equation for x. Well, let's get the x minus 2 quantity squared by itself. I'm subtracting 1. I need to add 1 to both sides. So that means I'm going to have x minus 2 quantity squared is equal to 1. And then next, the opposite of squaring something would be to take its square root on both sides. That will leave me with just x minus 2. And I do need to include the plus or minus. Anytime you take the square root, you always include plus or minus. So it'll be x minus 2 is equal to plus or minus 1. That means I have two equations. X minus 2 is equal to 1. X minus 2 is equal to negative 1. So here for x minus 2 is equal to 1, if I add 2, that would mean x is equal to 3. And then for x minus 2 is equal to negative 1, if I add 2, I get x is equal to 1. So my x-intercepts are 3, 0, and 1, 0. Now that's one where you can verify the fact that you have your x-intercepts here. you can probably just look at the graph, you'll see at 1, 0 and at 3, 0 are your x-intercepts. This is just another way of coming up with your x-intercepts. Now for the y-intercept, of course, we just let x equal 0. So we just evaluate g of 0. So g of 0 will be just this 0 minus 2, quantity squared minus 1. 0 minus 2 will be -2, and that's squared minus 1. This will mean 4 minus 1, which is 3. So the y-intercept is, of course, 0, 3. And you probably can see that from right here from that graph. The graph crosses the y-axis at 3. Now, part B is finding the vertex. Again, you can get that from the graph, or we can use h comma k. H is always going to be the opposite sign here. It says -2, so that 2 will have to be +2. And then the k, of course, -1. And you can verify from right here, because here's the vertex, 2, -1, to the right 2 and down 1. Now, of course, maximum and minimum, or minimum. This time, your vertex is the lowest point on the graph since the graph is opening upward. So that means we have a minimum value of our y-coordinate from that vertex, -1. And then part D, of course, is finding the range. Well, the minimum is -1, so that means our range has to be -1 with a bracket, and it goes on and on without end, upward, infinity. So -1 to infinity with -1 included, that would be your range for this quadratic function. Okay. All right, next we're going to find the vertex form of the function, and then find each of the following. Starting with the x-intercepts, the vertex, the maximum or minimum, and the range. So here I get S of x is equal to x squared minus 4x plus 3. All right, the way I'm going to find the vertex form, and I want you to follow along with me on this one, is this. I'm going to group these first two terms in parentheses as x squared minus 4x in parentheses, and then the plus 3 on the outside. This is where I'm going to use completing the square. Okay. And I do have a video under one of the sections for quadratic functions or quadratic equations where we solved using the concept of completing the square. Also look for that, research that video as well in my channel. So here we got x squared minus 4x. And then I'm going to put some space here and then put the plus 3 here. The way we complete the square is this. I take 1/2 the coefficient of x and square it. In other words, if I take 1/2 of -4, that would be -2. And if I square the -2, I would get a +4. Okay, so here's what I'm going to do. I'm going to add 4 here. But if I add 4, I also have to subtract 4. Okay, and the reason why I'm doing that because I want to keep the equation the same without changing it. Okay, so if I add 4, I have to subtract 4. Now, what's in parentheses will be in what we call a perfect square trinomial, which I can factor into 2 binomials here. So I'm going to bring down s of x. That's going to equal to, and if I factor this out, and again, watch the videos for factoring under the college algebra resources that I have in the Getting Started module in Canvas. X squared would be x and x if I put this apart. Middle term is a minus, the last term is a plus, so I write down the minus sign. Factors of 4 will have to be 2 and 2. And then plus 3 minus 4 would be a minus 1 if I add those two. But I'm going to write that x plus 2, x minus 2 times x minus 2 as x minus 2 quantity squared minus 1. That would be Vertex form of the function s of x. Now, let's find the intercepts, both the x and the y intercepts. Okay. So part A is your x-intercepts. Of course, you take that function, x minus 2 quantity squared, set that equal to 0, x minus 2 quantity squared minus 1, and set it equal to 0. Now, to get this by itself, we're going to add 1 to both sides. So that means I'm going to have x minus 2 quantity squared is equal to 1. And then if I take the square root on both sides and include that plus or minus symbol, I will have x minus 2 is equal to plus or minus 1. That will mean x minus 2 is equal to 1, or x minus 2 is equal to negative 1. So now for the x minus 2 is equal to 1, if I add 2, you'll get x is equal to 3. And then for the x minus 2 is equal to negative 1, if I add 2, I would get x is equal to 1. So these are my x-intercepts here. Actually, x equals 3 and x equals 1. So then you might have to enter 3, 1 for your x-intercepts. And then for the y-intercept, let's see, I'll do this up here. Here we let x equal 0 and solve for y. Now you can use the vertex form and substitute 0 in for x, or you can use the original equation in standard form and substitute 0 in for x. Okay, probably I'll go ahead and use the original equation and just substitute 0 in for x. You're going to see it'll be easier to do it that way, which means 0 squared is 0, minus 4 times 0 is 0, plus 3. It ends up being 3. So your y-intercept will be 0, 3. So all of that represented part A. Part B is your vertex. Your vertex can be identified from this vertex form right here. It would take the opposite sign for your x-coordinate. It says minus 2, so it's going to be a positive 2. And we'll take the same sign for the 1, which is negative 1. So 2, negative 1 will be your vertex for that quadratic equation. Now, part C is determining whether we have a maximum and a minimum, and what is that maximum or minimum. Well, let's take a look at the coefficient in front of the parentheses. There's none there, but it's understood to be a 1 right here. It's positive, so that means we have a minimum. We have a minimum value at our y-coordinate, which is I'm sorry. Yeah, I'm okay. I look at the y-coordinate there, negative 1. So the minimum y value is going to be at -1. And I can look at the vertex here and look at that y coordinate. That would be your minimum value there, because the vertex is the lowest point in this case if it's opening upward, which it is. Part D is finding the range. Okay. Well, if it's a minimum value of -1, that means I'm going to have y values in bigger than 1, -1, since it's opening upward. So that means -1 up to infinity. And of course, if it is a minimum, then that means that the inequality that I'll have to use is y is greater than or equal to -1. Okay. All right, now here's another example of this one. Let's say we want the vertex form of this function, s of s is equal to -2 x squared minus 16x minus 30. We're going to find the intercepts, the vertex, and maximum or minimum, and the range. And in this case here, I'm just going to focus on these first two terms here. From these first two terms, I'm going to factor a negative. Well, I can do the whole thing because 30 has -2 in it. So let's factor out the -2. And then this will be x squared plus 8x plus 15. So now let's find the vertex form there. Bring down this -2 and just focus on these first two terms here. X squared plus 8x, and then plus. Now for this 15, I have to include the -2, so it'd be -2 times 15. Okay. Now I'm going to complete the square on this part right here. And I'll do -2 times 15, which is -30 anyway. Now, in this case here, I need to take 1/2 the coefficient of x and square it. That's completing the square. So 1/2 of 8 is 4. And then I need to square the 4. That'll be 16. So I'm going to add 16 here. But when I add 16, I also need to subtract 16. But notice I got the -2 in front. So I just can't add 16. I got to add 2 times 16. Or I mean subtract -2 times 16, which is -32. I got to subtract -2 times that 16, which is, of course, -32. And the reason for that is that that -2 is in front of the parentheses. Now, this will factor as a perfect square trinomial here. So I had the -2 times x, let's see, plus 4, because half of 4 is 8. Half of 8 is 4. So it'll be x plus 4, that'll be squared. Now, in this case here, -30 minus a -32 ends up being 2. And I just did that in the calculator, so it'd be plus 2. So that would be the vertex form of that equation. Okay. That would be the vertex form of this equation. -2 times the quantity x plus 4 squared plus 2. From that, we can find our x and y intercepts. Okay, so starting with the x-intercepts, we take this -2 times the quantity x plus 4, that will be squared, plus 2, set that equal to 0, and solve for x. So here, if I subtract 2 on both sides, that means I get -2 times x plus 4, quantity squared, is equal to -2. And then divide both sides of this equation by -2. I'm going to have x plus 4, quantity squared, is equal to 1. And then if I take the square root on both sides of this equation and include that plus or minus symbol, that would mean I have x plus 4 is equal to plus or minus 1. That means x plus 4 is equal to 1, or x plus 4 is equal to -1. Now for the x plus 4 is equal to 1, that means x is equal to -3. And then for the x plus 4 is equal to -1, that would mean x is equal to -5. So my x-intercepts are going to be -3 and 5. Now for the y-intercept, we just substitute 0 in for x here. So s sub 0 is equal to -2 times 0 plus 4, quantity squared, plus 2. That would mean -2 times 0 plus 4 would be 4, that's squared, plus 2. 4 squared is 16. -2 times 16 is -32. -32 plus 2 would be -30. So your y-intercept there would be -30. So all of this represents part A, finding your intercepts. The B part is to find the vertex. Well, since this equation is in vertex form, I can identify that vertex from inspection. This is a plus 4, that means the 4 has to be negative. So it'll be -4, +2. So the vertex -4, 2 is for this quadratic function. Part C is a maximum or a minimum. Now, keep in mind, if the number in front of the parentheses when it's written in vertex form is negative, it opens downward. That means we have a maximum point. So we have a maximum at the y coordinates value, which is in this case 2. And of course, the range. If it's a maximum, that means the highest y value it will ever reach is 2. So we have to use something like y is less than or equal to 2. Sometimes they might use the interval from -infinity up to 2. This is a bracket. And that's parentheses. So that's the bracket. From -infinity to 2 would be your maximum. Usually they'll say y is less than or equal to 2. Okay. Now, while I'm on the subject of intervals, which I was using here in these examples, let's talk about interval notation. Here it is. Interval notation gives a convenient way to represent collections of numbers that are given as inequalities or as number line graphs. The table here summarizes comparisons of the various representations of collections of numbers in interval notation, inequality notation, and line graphs. And if you've had college algebra before, you pretty much should know what this is, what this looks like, what interval notation is. So do look over that. And I also have a video for college algebra in one of the sections in that college algebra playlist that talks about interval notation. I'll go over that in detail. So make sure you watch that if necessary. All right. In the table, the numbers A and B, with A less than B, are called the endpoints of the intervals. An interval is closed if the interval contains endpoints. And we use brackets to indicate where an interval is closed. An interval is open if it does not contain any of its endpoints. We use parentheses as well. But keep in mind, for infinity, both positive and negative infinity, we always use parentheses. Okay, so in this example, here we're going to use interval notation to write a solution set of the inequality below. Like 5x minus 2 is, 5x plus 2 is less than negative 11. Five x plus 2 is less than negative 11. So now to get x by itself, well, 5x by itself, we need to subtract 2 on both sides. That would mean 5x is less than negative 13. And then to solve for x, we're multiplying it by 5, so we need to divide both sides by 5. That means x is less than, and I'll leave this as negative 13 fifths. Okay, and I'm trying to check to see if they want this in, yeah. Okay, so now we just leave this as an improper fraction. Now, of course, for less than, x being less than that would mean something like this right here. And this would be the interval notation for that, negative infinity to that number with parentheses. So the interval notation would be from negative infinity to negative 13 fifths. Okay, so that's the interval notation that they want. Okay, here's another example. Let's say we had x squared minus 5x is greater than 0. X squared minus 5x is greater than 0. Now, in this case here, there are ways that you can find out what that is. But here, I'm going to find out what my x-intercepts are. And I'm going to treat this as x squared minus 5x is equal to 0. Now, there's a common factor in x squared and 5x, which is just x. So I'll just factor out the x, and I'll be left with x minus 5 is equal to 0. And then write this using the zero product property, where x will be equal to 0, and x minus 5 equals 0. X is equal to 0 is always solved for x, so for x minus 5 is equal to 0, that would mean x have to be equal to 5. So I know my two x-intercepts will be at 0 and 5. Now, if I use my graphing calculator, go to y equal to, let me clear this out. I'm going to type in that x squared minus 5x. So the way I did that, I get the x and then hit x squared to square it, and then minus 5 and then get the x. I'm going to graph this. Now, greater than 0 means that it has to be above the x-axis here, okay? So if you look at this graph here, you'll see at 0, this part is above the x-axis. And the interval for that would be from negative infinity up to 0. So that's one part of that interval. Or this part that's above the x-axis, it starts at 5. And it goes on up. And it remains above the x-axis. So from 5 to infinity. And the reason why I'm using parentheses because it's strictly greater than. So that means my endpoints are not going to be included. So from negative infinity to 0 and from 5 to infinity, that's the interval notation that satisfies that inequality. Okay. And here I'm just using the graphing calculator to help me find out where this graph will be above the x-axis, since it says greater than. If it said less than, now look at the part that's below it. Okay. All right, here's another example of that. X squared plus x minus 42 is less than or equal to 0. And if I can pull this paper up, you can see it. Here it is. Now, in this case, I'll treat this as x squared plus x minus 42 is equal to 0. And factor this into two binomials here. So in this case, that x squared, I'll break that up as x and x. The middle term is a plus and the last term is a minus. So this has to be plus, the other one has to be minus. I need factors of 42 that will give me x as a middle term. So it'd be 7 plus 7 and a negative 6. So it has to be x plus 7 times x minus 6 is equal to 0. Set each binomial factor equal to 0. So this will be 7, x plus 7 equal to 0, and x minus 6 is equal to 0. Now to solve for x plus 7 is equal to 0. That means x is equal to negative 7. And then for the x minus 6 is equal to 0. That means x is equal to 6. Now, watch what happens when I graph this. Let's see. Press y equal to. Get the x for your x and then square it. Plus. X theta n for your x minus 42. Graph. And it's got to be less than or equal to 0. That means that the part of the graph has to be below the x-axis. And if I, let me see if I can do this. If I do zoom fit, so you can see it a little bit better. Might not be the best, but it is. It is what it is. But pretty much you can see here, less than means it's below the x-axis. This part right here is below the x-axis. And those values that would be between those two values, where it's going to be below, would be negative 7 and 6. So the interval for that, and we do include it because it says less than or equal to negative 7, 6. Okay, because the part of the graph is below the x-axis, as you can see here. This part right here that I'm showing with my finger is below the x-axis, between negative 7 and positive 6. Okay. All right, here's another example using the graphing utility. Since I've been using that with these other two examples, so let's talk about that. In part A, you're to graph y equal 1.9x minus 2.5 in the rectangular coordinate system. Part B is to find the x and the y intercepts algebraically. Part C is to graph y is equal to 1.9 x minus 2.5 in the graphing calculator, and then find the x and the y-intercepts using the trace and the zero command. And here you're going to choose the correct graph. What I would do here is try to find the one that has the y-intercept of a negative 2.5. It's got to be crossing the y-axis at negative 2.5. And I know A is not going to be the answer. And I know D will not be the answer. It had to be between A and C. Okay. And I also need to, I also need to know this. The slope is positive. That means it's got to be rising from left to right. So between B and C, B is falling from left to right. This line is falling from left to right. It must be C. So here I'm using process of elimination to eliminate those wrong answers and narrow it down to the correct answer. So it has to be C, because notice the slope is positive, so it's got to be rising from left to right. The y-intercept is 2.5. Okay. This doesn't have a y-intercept of 2.5, and this one didn't have a y-intercept of 2.5. And this one is falling from left to right. The slope has to be rising from left to right because 1.9 is positive. So the answer there is C. Okay, part B. What is the x-intercept and y-intercept? Okay, let's see. My x-intercept, we let y equal 0. So here, this y will be replaced with 0. So it'll be 0 is equal to 1.9x minus 2.5. Now, if I add 2.5 to both sides, it'll be 2.5 is equal to 1.9x. Divide both sides by 1.9. Now, they did say give the answer to one decimal place. So let me go back to this. 2.5 divided by 1.9 would give me 1.315. But to one decimal place, it'd be approximately 1.3. So my x-intercept is approximately 1.3. Now for the y-intercept, we let x equal 0 and solve for y. This should be easy. So here y is equal to 1.9 times 0 minus 2.5. Well, 1.9 times 0 is 0. 0 minus 2.5 would be negative 2.5. So my y-intercept is a negative 2.5. So that's part B right there. Part C is to graph y is equal to 1.9 minus 1.9x minus 2.5 in the graphing calculator. So if I go to y equal to, let's clear this equation out and type in 1.9, get the x, and then minus 2.5. I'm going to do zoom 6. We should know that it is going to be a straight line. And I'm going to change the window here, because in the problem, I'm going to move this paper up, it does say from negative 5 to 5, which means the x minimum will be negative 5, the x max will be 5, the increment, the x scale will be 1. And the y min would be from negative 5, y max will be 5 with an increment of 1. So I'm going to press graph. This will give you a better view of what that graph looks like, as you can see here. All right, so they say use the trace command. So if I press the button that says trace, you'll see at x equals 0 is negative 2.5 for your y. That's your y-intercept. And then if I use my right arrow key, now, if I want to find the 0 or the x-intercept, here's what I do. I go to second, and trace. And I'm going to select menu item number 2. Second and trace gives you the 0. Gives you the menu item. I'll do it again. Second and trace gives you the calculate menu. Then you're going to select number 2 for your 0. All right, so now the cursor needs to be below. So I'm going to use my left arrow key to put the cursor below that intercept and press enter. And then I'm going to use my right arrow key to put the cursor above that Xintercept and press enter. And then after guess, press enter. You'll see the 0 or your Xintercept, which is in this case to 1 decimal place, 1.3. Okay. And they ask you to choose the correct graph. So if I look at this graph with the others, it will have to be graph D. Has to be. And then, of course, find the X-intercept and the Y-intercept. We already found those. That's just going to be 1.3 for your X-intercept. The Y-intercept, of course, is negative 2.5. Okay. Using the graphing calculator. I just showed you how to do that. Okay. All right, so here's another example using a graphic utility. In this case here, we got f of x is equal to 0.4 x squared minus x minus 2. And we're going to solve each equation graphically to 2 decimal places. In part A, we're going to be dealing with for f of x equal to 5. And we want to find out which of the following graphs should be used to find solutions of f of x is equal to 5. Okay, here's how we enter that in. Let's see. Let's go to y equal 2, and I'm going to clear this equation out and enter this equation as 0.4. Press the xt theta n for your x, and then square it with the x squared key, minus x, and then minus 2. That's going to go in y1. Now in y2, we're dealing with f of x is equal to 5, so I'm going to type in the number 5. Then I'm going to do zoom 6 for the standard window. Now you're going to see 2 different lines here. Well, actually, the curve and then the line itself. And it's intersecting at 2 different places. Okay, as you can see. So now we want to find those places where they intersect. So to do that, we're going to do second and trace. For our calculate menu, we're going to find the intersection. Excuse me. So I'm going to select menu item number 5 in the intersection. Now I'm going to find this first point of intersection, which is right here. So I'm going to use my left arrow key to put the cursor above that point of intersection, press enter. And then I'm going to use my right arrow key to put the cursor below. Oops. I have to be right here. Then enter. And then after guess, press enter. That would be my first point of intersection right there. And that would be, in this case, if I was to round this out to 2 decimal places, it would be negative 3.12. Yeah. So that first point of intersection would be negative 3.12. But I have to find the other point of intersection, which is way over here. So again, I'm going to do second and trace. Select number 5 for the intersection. Now for the curve, I'm going to put the cursor below that second point of intersection, and then press enter. And then for the second one, I'm going to put the cursor somewhere on the right-hand side of that point of intersection. Press enter, and then press enter again, and that will give me my other point of intersection, which is, in this case, 5.62. If I was to round that off to 2 decimal places. So 5.62 is the other point of intersection. Okay, so those are my 2 solutions there. And that's what part A is asking for in that problem. Now, what about for x is equal to -1? All right, so let's go to y equal to, I'm going to keep that first equation in y1, but I'm going to change y2 to -1. Then I'm going to do zoom 6 again. Okay. Now we're going to find the intersections at these 2 points here, starting with this one on the left-hand side. So I'll do second, trace, select number 5 for the point of intersection. Put the cursor above that point of intersection, like I'm doing right now, and press enter. And then put the cursor on the right-hand side of that point of intersection and press enter. After guess, press enter. So there's your point of intersection here. And they want this to 2 decimal places as well. So this will be negative, help me out, negative 0.77. Yeah. So in this case here, negative 0.77 is one of those points of intersections. And by the way, let's select the graph that is the same as the one I have here. Can't be A and it can't be B. It would have to be C, because that -1 is close to the x-axis, so it has to be C. Now for this point of intersection here, I'm going to do second and trace, and then select number 5 for the point of intersection. Cursor will be below that point of that point of intersection over here. Press enter. And then the other one will be to the right of that, like this, and then press enter. After guess, press enter. To 2 decimal places, it'll be 3.27. So that's how you find your points of intersections here. And then part C asks for f of x is equal to -8. Okay, that's this part right here. So we keep the same equation in y1, but we're going to go to y2 and change that to -8. Then zoom 6. And the graph that fits this one will have to be D. I'm sorry. Has to be A. Yeah, has to be A, because D, doesn't look like, this looks better. It'll have to be A in this case. Now, to find the solutions here, there's no points of intersection here. Look where f of x equal -8 is, and look where the graph of our parabola is. There's no points of intersection. That means that there are no solutions. There are no solutions here. Okay. All right, so do be familiar with using a graphing utility to do these types of problems here. All right, next we'll look at linear regression. Linear regression. Linear regression is a process where numerical information is analyzed and a linear function is found that matches the numerical information as closely as possible. The resulting linear function is called the best fit line. Calculating other technology processes are often used to produce a scatter plot graph of the points in a data set and to find a linear regression model. So when we create a scatter plot, we always do this. We use the calculated steps to create a scatter plot of a data set, that is to input the data, set the data type of plot desired, and then graph the scatter plot in a suitable window. Okay. So in example 17, here we got the figure shown to the right containing a scatter plot of 10 data points for trees, where the diameter of a tree at breast height, dBH in short, is given in inches, and the height is given in feet. The regression model is shown below, where X is the dBH in inches and Y is the height in feet. And here's the equation. Y is equal to 0.97x plus 4.67. And in part A, we want to interpret the slope of the model. And we have these 4 choices here. Well, I see that the slope there represents a change in the breast height to the height itself. Okay. Well, actually, it's going to be the rate of change of height with respect to the dBH, because that's the 0.97 represents. That's your slope in this case. Rate of change in height with respect to the rate of change of the height, because notice here, the height is your y-axis, dBH is your x-axis, change in y divided by the change in x. So it'd be the change in the height divided by the change in dBH. So it must be answer B. Then part B asks, what is the effect of 1 inch increase in dBH? So a 1 inch increase in dBH produces a, and of course that's going to be the slope, right here, 0.97 foot increase in height. And then you're going to use this formula to estimate the height of a tree with a dBH of 15 inches. So all we do there is just substitute 15 for X in that formula. So in this case here, for part C, I'll write the equation y is equal to 0.97x plus 4.67. So we just substitute our X with 15. So this is what X is. So that means y is equal to, using our calculator, do second quit, 0.97 times 15 plus 4.67 would give us 19.22. And I think they want this to the nearest foot or to the nearest whole number, so just be 19. So y is approximately 19 feet. And estimate the dBH of a tree that is 25 feet tall. So X in this case is going to be 25. So it'd be y is equal to 0.97 times 25 plus 4.67. So it'll be 0.97 times 25 plus 4.67 will give us approximately 29. Wait a minute, I think I did that wrong. This is not going to be X. This is going to be, I think, going to be Y. Because here they're asking for the DBH. So I did that all wrong. So in this case here, your Y is going to be 25. That's equal to 0.97x plus 4.97. So everyone see that because the height of the tree is what Y is. Your DBH is your X. So here we're finding out the DBH of the tree. So we need to solve this equation by subtracting 4.97 on both sides. So that means, let's see, 25 minus 4.97 gives me 20.03. That's equal to 0.97x. And then we divide both sides by 0.97. So that means x is equal to 20.6, approximately 21 to the nearest whole number. So the DBH of the tree is 21. Okay. So here they're giving you the height of the tree. You just have to find the DBH, and the height of the tree is represented by Y. Your DBH is going to be represented by X. So my apologies for that mix up. All right. Now let's take a look at this example right here. And I got 2 left, and I'll be done with this video. Using a graphing calculator to find the linear regression model for the men's 100-meter freestyle data given in the table on the right, where X is years since 1980 and Y is the winning time in seconds. Do the same for women's 100-meter freestyle data. Do these models indicate that the women will eventually catch up with the men? So we're finding 2 linear equations, one for men and the other one for women. And I do need to mention something else here. This is where we use our graphing calculator. I need to modify these years because in the problem it says X is going to be the number of years since 1980. They give us a year, so we need to write this in terms of X. So if I subtract 1980 minus 1980, that's 0. 1984 minus 1980 will be 4. 88 from 80 will be 8. This will have to be 12, 16, 20, 24, 28. I subtract the year, each year from 1980 minus 1980 to get those numbers. Now here's how we enter this in the calculator. We're going to use the table. So now, let me clear this out. We're going to press the stat button right here, STAT. And I'm going to edit. So I'm going to select number 1 for edit. Now I have nothing in L1 and L2 and L3. But if I did, I will have to use my up arrow key, press clear, then enter to clear out any columns that I have values in them. Now, this right here, the years, which I converted from numbers from 0 to 28, I will enter those in L1. So I'll start with 0, then 4, 8, 12, 16, 20, 24, 28. And you have to press enter after each one of those numbers. Now for the men, and by the way, this went into L1. For the men, this will go into L2, and for the women, it will go into L3. So for men, I'm going to use my right arrow key, enter these numbers in L1. So this will be 50.40, and then 49.80, 48.63, 49.02, 48.74, 48.48, 48.17, 47.21. And then go to L3, this will be 54.79, 55.92, 55.00, 54.65, 54.50, 53.83, 53.84, and then 53.12. And again, you have to press enter there. Now we're going to come up with a linear regression equation for this. So I'm going to do second and quit for that. And then for the linear regression equation, I'm going to press the stat key, which is this button right here. Use my right arrow key to go to the calculation menu. Now I'm doing a linear regression. So I'm going to select menu item number 4 that says lin reg ax plus b. That is what we call linear regression. Press enter. You'll get this. Your X list will be L1, which is going to be the years converted from 0 to 28. That's L1. That's the one I want. Your Y list will be for men, L2. That's where I stored that data set in, L2. So these two will remain the same. Frequency list, I'll leave that alone. Store regression equation, I'll leave that alone. I go down to calculate. Hit enter. Now this is going to give you in terms of y equal ax plus b, where a is that number, this number here, and b is this number right here. And they want this to 3 decimal places. So when you write that linear regression equation for the men, it's going to be y is equal to your a to 3 decimal places will be negative 0.093. With the x behind it, plus b to 3 decimal places will be 50.107. Now that is the men's linear regression model for this situation here. Now for women. Now notice for women, it was stored in L3. So I'm going to go through the same procedure, press the stat key, use the right arrow key for the calculate menu, select menu item number 4 for the linear regression model. Now L1 is going to stay the same. That's the years. But this time the women were stored in L3. So when I go down the Y list, I need to change that to L3. And the way I'm going to do that, I will select the second key, and then select number 3 for L3, because right above it is L3. So I'm going to press number 3. It's going to change that to L3, L1, and then L3. Frequency list, I'll leave blank. Store regression equation, leave that blank. Highlight calculate, press enter. Okay. So here's my linear regression equation, which will be y is equal to 3 decimal places, that would be negative 0.77x. And then plus 55.529. Yeah. Righty. That's the women's linear regression equation. Now, based on that regression model, will the women's time eventually catch up to the men's time? And unfortunately, it doesn't look like it will, okay? Because the men's time, if I look at the y-intercept, that's faster than the women's time. So the answer there will obviously be no, it won't. Okay. All right, the last thing in this video will be the quadratic regression. It is a process where numerical information is analyzed and a quadratic function is found that matches the numerical information as closely as possible. All right, so the resulting quadratic function is called a best fit parabola. Calculating and other technology processes are often used to produce a scatter plot graph of the points in a data set and to find the quadratic regression model. So on the last page here, this is what we have. Here we're going to use a table. It gives the performance data for a boat powered by a certain outboard motor. We want to find the quadratic regression model, which is, of course, y equal ax squared plus bx plus c for a boat speed y in miles per hour as a function of the engine speed in revolutions per minute. Estimate the boat speed at an engine speed of 3,100 revolutions per minute. Okay, so here's what we're going to do here. In our calculator, the RPM will go into L1. MPH, miles per hour, will be in L2. So bring up a calculator, press the stat key. We're going to edit, so we're going to select number 1 for edit. Now notice we got stuff in our calculator, so what we need to do here is edit this out. I mean, clear these columns out. So we go up to highlight L1 using the up arrow key, press clear, enter. Go over to L2, use the up arrow key, clear, enter. Right arrow key to go to the next column, up arrow key to highlight L3, clear, enter. All right. So in this case here, L1 would be the revolutions per minute, 1,500, then 2,000, 2,500, 3,000, 3,500. Must press enter after each of those data values, especially the last one. Right arrow key to L2. Your miles per hour is 4.8, 5.7, 7.8, 9.6, 9.6, and 13.4. And I do need to warn you that make sure that you enter your data values correctly and make sure that you have the same number of data values in L1 as you do in L2. Otherwise, it's not going to come out right. Now for the quadratic regression model, I'm going to do second and mode to get out of it. I'm going to press the stat key. I'm going to use my right arrow key to go into the calculate menu. We're dealing with a quadratic regression model, so I'm selecting number 5 for the quadratic regression model, quadreg. That's short for quadratic regression. Press enter. X-list is L1. I need to change my y-list from L1 from L3 to L2, so I'm going to do second and number 2. Second, number 2 gives me L2 because I only stored L1 and L2. Frequency list, I'll leave blank. Store regression equation, I'm going to leave that blank. Go to calculate, press enter. Okay. So now in this case here, notice it's already set up like that because it has this with the e to the -6 because they expect that you were going to get an answer like that with an e to the -6 for A. But for the 1 decimal place, let's see, 1.6 would go there for the A. because that's what A is equal to. B, from here to, help me out, 5 decimal places, they give us that negative 0.00364. The fifth number is a 3, the 7 makes it a 3 or 4, so it'll be negative 0.00364. And then for you C, to the nearest tenth to 1 decimal place, 6.7. All right. So that's how we find the quadratic regression equation. Now, in this case here, what is the estimated boat speed at an engine speed of 3,100 revolutions per minute? All right, and here we're going to have to use the answers from the previous step to find this answer. Okay. Now, this might be the hard part right there, just getting the quadratic regression equation here. So, okay. Well, I'll tell you what. So for a problem like this, I would convert this to, I would use that 1.6, write that as a number to 6 to in standard form, because it's in scientific notation. This will be something like, let's say 0 point, and I know I need to move the decimal point 1 place to the left, so I need 5 zeros in front. And then 1/6 times X, in this case, is going to be 3,100. Let's see, since it's a negative, it's going to be minus 0.00364 times X, which is 3,100, plus 6.7. And I'll go ahead and show you how that's going to be typed into the calculator. 0.003450, and then 1/6 times 3,100 plus, not plus, minus 0.00364 times 3,100 plus 6.7. Let's see, to the nearest tenth, it would be approximately, and I think I did that all wrong there. This needs to be squared. That's the problem, because it's a quadratic. Okay, so let's try that again. Times 3,100, that's going to be squared. Minus 0.00364 times 3,100 plus 6.7. There we go. So to 1 decimal place, it'll be approximately 10.8. So the approximate boat speed at an engine speed of 31,000 revolutions per minute would be approximately 10.8 miles per hour. Okay. So in this case here, it was a quadratic, so I ended up forgetting the square. So you have to square that first because it is quadratic. Okay. So that does conclude this lengthy video on section 1.3 dealing with things like linear and quadratic functions. So feel free to reach out to me if you have any questions about anything presented in this video or any of the homework problems, especially putting values like this in the calculator. So reach out to me if you need help.